So this is example number 1 for dimensionless analysis. To do this and better understand how the Buckingham theorem actually works, let's consider the following case. Let's consider a case in which you have uh, a function f, and let's say that function f is a function of pi 1, pi 2, and pi 3. Okay, and we would like to find these functions for which this aerodynamic function is a function of. For these purposes, now let's assume that f1, if pi is actually a function, is some function of another function that maybe is rho, is density, is velocity, chord, and your Reynolds number. Okay, let's suppose I have another function. It's a different function, and it's a function of rho, b, chord, and viscosity. Let's suppose I have another function that is a function of 5, that would be rho, v, c, and my speed of sound a. Okay, so what we know is, we know the following. We know that my Reynolds number, the dimensions are m, l, t minus 2. We know that your rho's dimensions are m, l minus 3. We know that your v dimension is l, t minus 1. We know your c dimension is l. We know your density dimension is m, l minus 1, t minus 1. And we know speed of sound is l, t minus 1. So we know all this. So we know that these are all, these dimensions of each one of these quantities is actually equal to that. We're going to use this to find a relationship inside here. To find the relationship, let's start with our first one, where we said pi 1 is equal to f3 times rho infinite, rho, let's forget about the infinite. Infinite typically means that it's free stream, the speed of the stream of the aircraft, but let's be a little bit sloppy and forget about that for a moment. So what we're going to do is we're going to say pi is actually going to equal to rho times rho a is going, or let's call it d just for difference, vb, ce, and then we have the Reynolds number. Remember, this is already a non-dimensional quantity, so therefore we don't have to put another variable on top of that. Okay, so we know that this is also equal to, if we're going to just use our dimension analysis, we know this is d, we know this is l, this is t to the minus 1, this is b, we know this is l to the e power, and this is my, and also I know my Reynolds number. Reynolds number is nothing else than m, l, t minus 2. Okay, so we know that. And this comes from here, right? It comes from this analysis, and all we are doing is replacing everything inside this equation. So what we do here is, the whole idea is to make sure my right-hand side is completely and fully dimensionless, so it doesn't have any dimensions. Okay, so if we were going to do this, that means that what we are saying is that m times d, m here, and then I have let me change the colors. Um, L, oops, L minus 3D, LB, LE, L, that's here, and then I have time. Time is minus B minus 2. Okay, so, and what we want to make sure is that all of these quantities are 0. So that means from here, I know that D plus 1 has to be 0. I know from here, minus 3D plus B plus E plus 1 have to be 0. And I know that here, minus 2 minus minus B minus 2 have to be 0. Because remember, what I am doing here is I'm adding, I can add all the coefficients together, and that's how I get this. Okay, or just writing this completely minus 2 to be like the other ones. Okay, so now I'm going to proceed to go and solve for these values. So if you solve for those coefficients, you solve for D plus 1 is equal to 0. And you solve for minus 3 plus B plus E plus 1 equal to 0. Minus B uh, minus 2 is equal to 0. And from this one, you find that D is equal to minus 1. From here, you find that B is equal to minus 2. And I take these two equations and I plug them inside here. And you can find that E is equal to minus 2. So if I go back and I replace all that inside this equation right here, okay, I take this equation and I bring it back here and I say, now this will completely equal to R E. I have rho to the minus 1, V to the minus 1, and the chord length to the squared power. Okay, replacing all these quantities here, minus, sorry. So I can also write this, I have this RE times rho V squared times C squared. So this is the first pi, and this will be completely dimensionless parameter. So many times what we could do is we could go ahead, if you just remember, and we can multiply this by any number, is still a constant, and replacing this bit by my s, then I can basically go ahead and rewrite this whole thing, and I could say, hey, this is the same as my Reynolds number divided by 1/2 rho times V squared times S. But so this coefficient that we are saying this will be completely dimensionless if I did that. Okay? So let's go to the second function that we had. Remember that we were solving this. We said this was function of pi 1, pi 2, pi 3. Let's go with this second one. The second one, let's say we got the pi 2. In this particular case, rho V, let's call letter H, I, and J. This is completely arbitrary numbers. You can use whatever value you wanted to do there. This is M, L minus 3, the first term. My speed is length times time minus 1 times h to the hth power, length to the ith power, m l minus 1 t minus 1 to the jth power. And you can see from here, you're going to get m1 plus j. I got a m here, 1, and then this times this will give me j. And I can say L, this will be minus 3 plus h plus I, this is I, plus, minus j, and then I have time. Time will be minus h minus j. And all these coefficients have to be 0. Okay? So setting all these coefficients to 0 equal to 0, minus 3 plus h plus I plus minus j is equal to 0, and minus h minus j equal to 0. From here, we find that j is equal to minus 1, h is equal to 1, and I is equal to 1. So from here, what we are saying is that your equation pi 2 is nothing else than rho infinite v infinite c over mu. I'm sorry, the infinites don't go there. I'm not using infinite. So this is what your equation looks like. Okay, and so this particular equation is nothing else than a free stream Reynolds number. So this is also a Reynolds number. This is a free stream Reynolds number, which is also very, very useful in many type of equations. So the second equation that we want to use, let's say pi 3. So I have pi 3, and pi 3 we said was b, rho, c, and a. This is to the k, this is r, this is s. This comes back to this equation right here. Okay, a, b, c, rho, b, c, and a. So we want to solve for that, and I put all these variables there to find what the coefficients are. We do exactly the same process again. This is length time minus 1. This is mass over length squared. That's just minus 3 over the kth power. And this is length r. This is LT minus 1 to the s power. And then from here, what you can show is that your equations are k is equal to 0, 1 minus 3k plus r plus s is equal to 0, minus 1 minus s is equal to 0. And from here, you solve for k is equal to 0, s is equal to minus 1, r is equal to 0. So basically, another form of pi 3, we are saying is nothing else than b over a. And note that this is the free stream Mach number. Okay, so in the same context, same way, we can find many, 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 many different coefficients, and we are basically trying to say the following. We are saying, hey, my function that I started with was nothing else than a function of my Reynolds number, 1/2 rho v squared over s. This is rho vc over mu. This is nothing else than the Mach number. We usually use double, so we write it like this typically. And that has to be 0. So what we are saying is, if you look at this, if you remember, we are saying this is nothing else than CR, so it's non-dimensional. This is nothing else than your Reynolds number. This is nothing else than your Mach number. Okay, so in other words, what I could write it, I could say this coefficient right here is nothing else than it's going to be a function of function, let's say call it function 6, of my Reynolds number and my Mach number. So this is how we actually do the dimensionless analysis, and we can find many different variations on things depending on what we are interested in and what we really want to. Um, One straight application of these problems are the following. Well, you can, and we will be able to show this later, that your coefficient of lift is going to be a function of your Reynolds number. Coefficient is going to be a function of your Mach number and your angle of attack. And the same thing here. This is going to be a function of your Reynolds number, function of your Mach number, and your angle of attack. And your moment is going to be a function of your moment, Reynolds number, and my Mach number, and my angle of attack. And if you're just wondering what the angle of attack is nothing else than I have my airfoil at the angle at which my speed is hitting my aircraft. This angle right here is called the angle of attack. Okay, so this concludes this example for dimensional analysis.